All right, guys. Good day, class, or wherever you are. Just a pleasant greeting. All right, guys. Today I'm going to be looking at something very simple. Very simple. Just the aim of this is to start very simple and break them down. Now we want to look at atomic structure. Atomic structure and how WAEC, JAMB, and post-JAM ask their questions. This topic is very simple, but a lot of chemistry students, due to poor background, cannot find their way when a question is asked from here. So atomic structure. The very first thing you have to know is that an atom is the smallest. An atom is the smallest indivisible, the smallest indivisible particle of an element. Who said this? Is no other man than John Dalton. However, it was discovered that atom is not the smallest anyway. But today I'm just going to take a piece of that. So according to John Dalton, atom is the smallest indivisible particle. Okay. Now, atom being the smallest, it was also discovered that atom has two parts. There are two parts of an atom. An atom has two parts, which can be the outer part is the shell, while the inner part of an atom is the nucleus. So shell and nucleus, those are the parts of an atom. So quickly, we can draw that. So we'll say an atom has two parts. And what are those parts? You have the shell, and then this is the shell of an atom. Then you have the nucleus of an atom. So shell and nucleus. Now, it was also discovered that atom has three subatomic particles. But atom is not actually the smallest. It has three subatomic particles. What are those three subatomic particles? Number one, you have the proton. Number two, you have the electrons. And number three, you have the neutrons. So that means atom has three subatomic particles: proton, electron, and neutron. Like I said, this video is targeted to those people who probably their foundation is not so strong. They jump this basic topic in chemistry, or they just want to refresh their memory. So proton, electron, and neutron. Proton is positively charged. Electron is negatively charged. And neutron has no charge. That means neutron is usually neutral in an atom. So proton is positive, electron is negative, and neutron is neutral. All right, where are they found inside an atom? Remember I said atom has two parts: the nucleus, the inner part, and the shell, the outer part. So you have proton, electron, and neutron. All right, having known that, so where is proton found? Proton is usually found inside the nucleus of an atom. So I can say proton is found inside the nucleus of an atom. Proton as well as neutron, they are found inside the nucleus, whereas electron is found on the shell. So what is the location of proton? Proton is located inside the nucleus, while electron is on the shell, the neutron is also found inside the nucleus. So proton and neutron, they are found inside the nucleus of an atom. Okay, that's not all about that. Now pay attention very well. Now, we have noted the particles which are proton, electron, and neutron. What is the charge? Positively charged. Charge, negatively charged. This one is neutral. That means neutron is neutral. Where is proton found? It's found inside the nucleus of an atom. Electron is found on the shell. Neutron is found inside the nucleus of an atom. Okay, so what's the mass of proton? The mass of proton is 1. What's the mass of electron? The mass of proton is 1. The mass of electron is 1 over 1840. 1 over 1840. The neutron mass is 1. There was a year in JAMB, they said, which of the following contributes least to the mass of an atom? The particle that contributes least to the mass of an atom is the electron. Why? It is 1840 times less than the mass of proton and neutron. That means the mass of proton and neutron, they are bigger than the mass of electron. That's what I mean. So, if you are given a question, which of the following contributes least to the mass of an atom? The answer is electron. Okay, so still on this, because I want to take it very cool so that you can get the basis of this atomic structure. So atomic structure talks about the parts, the particles in an atom, and what they consist. That is what we mean by atomic structure. Now, I said an atom is part of an element. So the next thing is, what is an element? What is an element? You often say an element is a substance which cannot be divided into two by any chemical means. Very elementary. An element is a substance. Of course, we are dealing with the elementary part of chemistry. An element is a substance that cannot be split into two by any chemical means. As a chemistry student that is just starting, how many elements should you know? You must know 1 to 30 elements. 1 to 30 elements. What do you mean, Doki? You must know hydrogen all the way to zinc. So I'm going to do justice to that right away. Now, what is element number 1? Element number 1 is hydrogen. So hydrogen is element number 1. The symbol of hydrogen is H. Element number 2 is helium. Element number 2 is helium. Then what is element number 3? Element number 3 is lithium. That's lithium. And the symbol is Li. What's element number 4? Element number 4 is beryllium. And the symbol is Be. So I have hydrogen, helium, lithium, beryllium. Number 5 is boron. Boron is B. Element number 6. Element number 6 is carbon. That's C. Element number 7 is nitrogen. Element number 7 is nitrogen. That is number 7. Element number 8 is oxygen. That's that. Oxygen. Element number 9 is fluorine. Fluorine. That symbol is F. So I have 1 hydrogen, helium is 2, lithium is 3, beryllium is 4. You have boron is 5. Carbon is 6. Now 7 for nitrogen. Oxygen is 8, and then 9 is fluorine. All these numbers here are known as the atomic numbers. So if you are asked, what is the atomic number of hydrogen? Answer is 1. What is the atomic number of helium? Answer is 2. Atomic number of lithium? Answer is 3. So I'm going to start from number 10. Then we go to element number 10. What is element number 10? Element number 10 is neon. That's element number 10. Now, the symbol of neon is Ne. Then we move to element number 11. Element number 11 is sodium, and the symbol is Na. What is element number 12? Element number 12 is magnesium, and the symbol is Mg. What's element number 13? Element number 13 is aluminium. Aluminium, and the symbol is Al rather. What's element number 14? Element number 14 is silicon, and the symbol is Si. What's element 15? Element 15 is phosphorus, and the symbol is P. What's element 16? Element 16 is sulfur. The symbol is X. Now remember, all these numbers are known as the atomic number of the elements. So atomic number of neon is 10. Atomic number of sodium is 11. Atomic number of magnesium is 12. Atomic number of aluminium is 13. Atomic number of silicon is 14. Atomic number of phosphorus is 15. Then sulfur is 16. So let's go to element number 17. Element number 17, that's element 17, is chlorine. Cl, that's the symbol. Element 18 is argon. Then that is Ar. Element 19 is potassium. Potassium, symbol is K. Then you go to element number 20 is calcium, symbol is C. Now, remember I told you that all this nonsense, all these ones are called elements. They are called atomic number. Okay, so why do we refer to them as atomic number? You get to know that as the class proceeds. So I have 1 to 20 already. Now let's go to 21. 21 is scandium. Scandium is 21. Then 22 is titanium. That's fondly titanium. It's called titanium. Scandium is Sc. Titanium is Ti. Then element 23 is vanadium. That's V. Element 24 is chromium. That's Cr. Element 25 is manganese. Now, I want you to pay attention that manganese is different from magnesium. Magnesium is atomic number 12, and manganese is 25. Then here we go. 26. Element iron is 26. Then 27. Element cobalt. That is 27. 28. Element nickel. That's 28. Ni. All right, so 21 is scandium. 22 is titanium. 23 is vanadium. 24 is chromium. 25 is manganese. 26 is iron. 27 is cobalt. 28 is nickel. Now let's go to 29. Element 29 is copper. Element 29 is copper, and the symbol of copper is Cu. Element 30 is zinc. That's Zn. Now, I have given you 1 to 30 elements. as the basics of a chemistry student, you must know 1 to 30 elements. You are starting from there. Okay, so having known that, let's move on. 1 to 30 elements, all those numbers are known as atomic numbers. So I am going to take a subheading called atomic number. Subheading, atomic number. Now, so what is atomic number? Before I define atomic number, how do we represent it? It's represented with capital letter Z. So atomic number is represented with capital letter Z. So let's go. Atomic number can be defined as the number of protons present in an atom. Now remember that I told you that atom has 3 subatomic particles. If you remember, proton, electron, and neutron. So here we go. I just said that atomic number is the number of protons. So I call that one Z is equal to P. That is equation 1. Z is atomic number. P is the proton number. Now pay attention. Now I want you to notice what I want to do now. An element is said to be electrically neutral. An atom or element is said to be electrically neutral when the number of protons, that is positive charge, is equal to the number of negative charge, that is electrons. So element is said to be electrically neutral when that happens. So if that is the case, if P is equal to E, therefore Z is equal to E. I call that one equation 2. So it means that atomic number can have 2 definitions, one with a condition. First definition is defined as the number of protons present in an element or an atom. Very good. Or is defined as the number of electrons, provided that proton and electron are equal. Okay. The next thing is mass number. What is the mass number of an element? Before I can tell you what is mass number, what is the symbol of mass number? Is A. Mass number is represented with A. So what is mass number? Mass number is defined mathematically as the sum. Sum means addition. As the sum of proton and neutron. As the sum of proton and neutron. I call that one equation 3. So the sum of proton and neutron is known as mass number. Or you said the addition of the 2. So now remember that from equation 1, Z is equal to P. I can remove this P and put Z and say Z is plus N. That's A equal to Z plus N. Z represents atomic number, while N is the neutron number. So what can I do from here? Make N the subject of the formula. You can have N equal to A minus Z. I call that one equation 4. So let's go over this equation. Atomic number is the number of proton. That's equation 1. Provided proton and electron are equal, Z can be equal to E, meaning Z, which is atomic number, can be equal to proton number or equal to electron number, provided proton is equal to electron. So remember I said something. An atom is said to be electrically neutral when the number of protons is equal to the number of electrons. So what is now the implication? It means that if proton is equal to electron, atomic number can also be number of electron. That's the implication. Okay. Mass number is represented with capital letter A. So A is equal to P plus N. That's the sum of proton and neutron. And I went to derive how to get the neutron number, which is subtract the atomic number from the mass number. Okay, let me use this information now. Let's use this information now. In chemistry, how do you represent an element? If X is an element, you have A up here and Z here, which means A here represents mass number and Z here, that's how to represent it. A is a mass number, A is the mass number, YZ is the atomic number. Okay, so if I now give you a question like this, if an element phosphorus has atomic number of 15, and this one, now said determine the proton number, electron number, and neutron number. That will be very simple. Here, there's the position of the Z. Z is atomic number. Y31 is mass number. So what do we do? So it means from here, if A is already from here, if A is already 31, so my A is 31 and my Z is 15. So what do you do? Remember from equation 1 that we said that Z is equal to P. So if Z is 15, it means P will also be 15. That's proton. Equation 2 says that Z is equal to E. Now, if Z is equal to E and Z is already 15, that means E is also 15. Neutron number, last equation. Equation 4 says that neutron number is mass number minus atomic number. So what is mass number? Is 31. Atomic number is 15. Then that will be 16. Very simple. That will be 16. All right, now, guys, I'm going to use more of this formula and solve a lot of questions. But before I do that, how can an atom become an ion? There are two ways in which an atom can be transformed to be an ion. Number one is either they lose electron. Number two, or they gain electron. An atom can become an ion by either losing electron or gaining electron. If an atom loses electron, it becomes positively charged. It becomes positively charged. If an atom loses electron, it becomes positively charged. Whereas if an atom gains electron, it becomes negatively charged. I'll say that again. An atom can become ion in two ways. It's either they lose electron or they gain electron. An atom can lose electron. If it does that, it becomes positively charged. And the name of that positive charge is called cation. Cation. If an atom gains electron and becomes negatively charged, the name of that is known as anion. So anion is a negatively charged ion, while cation is a positively charged ion. Let's give an example. Please pay attention. Now, look at this. If I have sodium plus, this positive on it indicates that it has lost one electron. That's the meaning. The positive on it indicates that it has lost one electron. So what is that going to be? So if atomic number is 11, mass number is 23. So what do we do from here? Very simple. What is the proton number? Proton number does not change. It's the number of the elements that I listed from 1 to 30. It does not change. So proton becomes 11 here. But this atom is losing one electron. Subtract that 1 from 11. That means 1 from 11 will give you 10. So it means this element has lost one electron. Remove that 1 from 11 is 10. No problem. Let's move on. What is now the neutron number? 23 minus 11. That is mass number minus atomic number. So 23 minus 11, 23 minus 11 is going to give you 12. So it means for this ion, which is positively charged ion, proton is 11, electron is 10, neutron is 12. Okay, so let's look at this one. Magnesium ion. Don't worry, your question in your mind is how are you putting all these charges? Don't worry, in the next class you will learn how we are putting on these charges. It's not a problem at all. Just relax. So here we have 12 and we have 24 mass number. So here we go. Proton is 12. Then electron. This one is losing 2 electrons. Remove that 2 from 12. What you are going to have is 10. No problem. Now neutron. Neutron can be calculated by subtracting atomic number from the mass number. So this minus this, or 24 minus 12, that will be 24 minus 12. That will give us 12 as neutron number. No problem. Now, let's squeeze in this. This is aluminium, 13 and 27. Let's look at the proton number. The proton is 13. It does not change. Okay. The electron here is losing 3 electrons. So, plus, that is 3 plus, is losing 3 electrons. So, subtract that 3 from 13. That's 10. Now, let's get the neutron number. Very simple. Mass number minus atomic number. That will be 27 minus 13. And if you do that math, it's going to give you 14 neutron number. Now, I want you to take note of something. This is sodium ion, magnesium ion, aluminum ion. There's something that is striking. Look at this. Number of electron is 10. Number of electron is 10. And number of electron here is also 10. It means all these ions, they have the same number of electrons. They all have the same number of electrons. And whenever you have such condition in chemistry, when you have particles, atoms having the same number of electrons, it means that they are isoelectronics. So isoelectronics means particles with the same number of electrons. Particles with the same number of electrons. All right. So we are going to take a few questions and then you see what I'm going to do. Look at this. Now, look at this question. This is fluoride ion, 9, 19. When you see negative, it means it is gaining. Positive means it's losing. Negative means it is gaining. So it's gaining 1. Okay, no problem. Proton does not change. It's still 9. Electron now has changed. This element has gained 1 electron. So if you add that 1 to 9, that's going to be 10. Then the neutron number, 19 minus 9, that is 10. Okay, that's that. Now here we go. Look at oxide ion, 8 and 16. Oxide ion, 8 and 16. Proton does not change, that's 8. Electron is gaining 2 electrons. Add it to it, that is 10. And then the neutron number is 16 minus 8, that is 8. All right, let's squeeze in one more. Nitride ion. Okay, nitride ion, that's 7 and 14 mass number. Proton does not change, that's 7. Electron is gaining what? Is gaining 2 electron. 3 electron. 3 and 7, add it up, that's 10. Then you have the neutron number. The neutron number is 14 minus 7, that's 7. All right, again, they have the same number of electrons each. It means that they are isoelectronics. They are isoelectronics. Oh yeah. Now, I want to quickly wrap up because I want this video to be short so that you can take your time and don't be bored. All right. Now, if you look at elements, and that will be where I'm going to draw the curtain. Look at elements very well. There are 4 categories of elements. Category 1, they are the metals. So all the elements